This Altair 680 computer and the software that MIT's offered for it were all designed to use a teletype as the operator's console and as the mass storage device for the system. And of course, as soon as you have a teletype involved, you know that operation is going to be slow and loading large programs is going to be very slow. For example, in a previous video, I demonstrated that it takes about 35 minutes to load BASIC or the assembler editor package on this machine from paper tape through the teletype. And then once you've loaded that, you're probably going to turn around and load a program that you want to run or work on. And that's going to take another 5 or 10 minutes. So it's not unusual for the boot process to take about 45 minutes. And that's if everything goes smoothly, which, as I demonstrated, it doesn't always go smoothly. And that, of course, is just unbearable, especially if you're doing assembly language development where it's not hard to crash the system. And then you're having to do another 45 minutes to reboot just to figure out maybe what you might have done. And again, I think this is just unworkable, which is why in today's video, we're going to see what a hobbyist back in the day might have done to get around this bottleneck of the teletype. Instead of using a teletype, I'm going to try to use a normal CRT terminal as the operator's console, and then this high-speed reader you see on the left to replace the paper tape functions of the teletype. Now, one thing that's unique about the teletype is that the console, input, output, and the reader and the punch are all actually on the same serial port, all at the same baud rate. So we're going to have to emulate that somehow with these separate devices. And to do that, I'm going to use this DB25 switch box that you see here. So the common I/O on this switch box, of course, will go over to the Altair, to the single console port that it has. And then when it's on A, it will route data to and from our console. And when it's on B, it will route it to and from our paper tape reader. And so in that way, I'm hoping that we can pretty much just drop in and replace that teletype, but run at 9600 baud instead of 110. Now this particular paper tape reader is a bit newer than you would have found back in the Altair 680 days. This is from the 1980s. But really the only difference between this and a reader that might have been around in the mid-70s is that this has a very large RAM buffer in it. So to make this accurate, we're not going to use that RAM buffer at all, at which point this will act quite a bit like a paper tape reader from the mid-70s would have, that somebody might have picked up. Now this paper tape reader probably cost you more than the Altair. In fact, I know it would cost more than the Altair did. However, maybe you had an inside road to one of these with a discard from where you worked, or maybe you found one that needed fixing for a deal and you got it fixed and working now, and are going to try to figure out how to get this up and running on your 680 to speed up that teletype. All right, so let's go ahead and give this a whirl. First thing I want to do is try loading the assembler editor package from MIT's. Let me go ahead and turn on the 680, give it a hard reset. And then at this point, if we come over here and look, you can see that we're up and running. We've got our dot prompt from the monitor. And of course, let's just make sure it's all working. I can examine location 0, step through memory. All right, so this would be the same thing as having the teletype console, except it's nice and quiet and fast, of course. If we wanted to load software, for example, load the assembler editor, we would type L. And at this point, the computer is expecting paper tape data to come in through this same port in S-record format to load it. In fact, I can end the load process by typing S9, which is end of file for an S-record file. You can see we're back to the prompt. All right, now in this case, of course, I'm going to have to flip that AB switch over to our high-speed reader once I type L. Now before we load that, let's take a quick look inside the computer. The computer basically only has one expansion card installed, and that's a 16K static RAM board. 16K is good for running 8K BASIC or doing small programs in the assembler editor. If you want to run or design a big program in the assembler editor, you might need 32K of RAM. All right, so there's the tape. You can see it's gigantic. This is the biggest tapes I've ever seen, much bigger than they are over on the Altair 8800. And that's because of S-record encoding instead of binary, and we'll talk about that more in just a bit. All right, so I'm going to type the L command. Again, it's expecting data from the teletype paper tape reader. I'll switch it to our tape reader, and let me make sure this is turning freely. Yep, and I'll hit read, and off we go. Now this reader can read at about 400 characters per second, a little bit faster if it wasn't dragging trying to pull this long tape. So instead of taking 35 minutes, This is going to take about 50 seconds. It's about 40 times faster, which of course that's pleasurable. Now, one thing that's a bit of a mess, as you can see, we have quite a pile here on the floor developing. That's because I don't have a take-up spool that can keep up with this faster reader like I did on the teletype. So right after this is done, I'm going to have to do a video cut and wind that back up onto that spool. All right, so this should be finishing. Still seems like a long time, but it sure beats 35 minutes, and it's a lot quieter. All right, well, that's done. So now if I switch this AB switch back to the, I have no place to put this tripod down for all this paper. Sorry about that. Switch it back to the terminal, and what we hope is that we get our dot prompt, which means the whole tape came through with the S9. All right, so now if I jump to the entry address, there we are. We're up and running the editor portion of the assembler editor. I'm going to do a video cut and clean up this pile of paper on the floor so I don't step on it, and we'll continue from there. So unfortunately, my first attempt to demonstrate the editor did not work as expected because I forgot to set a variable called nsys in memory. Typically, you would go out here to the to the monitor and change 00D4. It's a 2-byte address to the top of memory that you want to assign to the editor and assembler. So I have a total of 16K on this card. The top address would be 3FFF. And I've saved the top 4K for my programs, forcing the editor and the assembler to stay below that top 4K. And I failed to do that, and so it ended up messing up my system. So anyway, that's all in there. I can jump to the editor assembler now. We're in the editor portion of it, and we have an empty file. We go to the beginning, type 99 lines, and it's empty. All right, so to input something into this editor, you use the I command, and everything you start typing now just goes into the edit buffer. So this is line 1, this, well, good enough, is line 2, this is line 3. Notice those carriage returns aren't terminating the command. In fact, carriage return never terminates the command in the editor. It's always hitting escape twice. So I'm going to type escape, escape, and now we're done with that I command. I can go to the beginning, type 99 lines, well, 999, how about that? Hit escape twice, and we can see the content of that file. All right, so what we want to do now is load a real program, and to do that, you can do it from paper tape using the I command as well, because it's just going to come in as if you were typing it. So let me clear out everything. I'll do, 99, kill 99 lines. So beginning 99 type should be empty now. It is. All right, so we can load a simple Hello World program I wrote in previous videos that I have on paper tape. I'm going to load that in with the I command. It's now expecting me to type that or pull it in from a paper tape. So I'm going to pull that in from this paper tape reader. I have it loaded right here. Switch this to B. Hit read. Go back to our console. It's a very short program. All right, so now I need to terminate that with 2 escapes. And if I go to the beginning and type 99 lines, you can see the Hello World program. All right, so this program was originally running up at 5,000, X5000 in RAM because I had 32K in here. So this is not going to run up there because I don't have RAM there, so I need to change that. So we can go to the beginning and then change 5,000, and then you type escape to separate your fields to 3,000. Terminate it again is 2 escapes. Type 20 lines, you can see it changed it to 3,000. All right, and this doesn't say Hello World, it says Altair 680. So let's change that to actually say Hello World. So I'll change Altair 680, hit escape to Hello World. Escape, escape. Beginning 99T, 2 escapes. Okay, now we have Hello World and we're at 3,000. So this should be happy for this system. Now let's go to the editor, excuse me, the assembler. That's with a G command. Don't overwrite it, I want to leave it there. You manually run the 2 passes. That was first pass. Here's the second pass, and we can see our program makes it nice and pretty. Exit to the monitor, jump to 3,000, and there's our Hello World. All right, so that's pretty easy to do. Let's go back to the editor. If I enter at A, it does not delete the content of the edit buffer. If I jump to 107 again, that edit buffer would be cleared. All right, so we have successfully loaded the assembler editor in under a minute, which is really nice. We can read source tapes that we punched before, assemble them. That all works great. It looks like we're on a roll, and this is a pretty simple fix. So now you've made these changes to the program, you want to punch a new tape with these updates. How would you do that? Well, the E command is what is used to end an edit session and punch the tape. So you just type E and hit escape twice, and then basically all the source data just comes to your port, so you would have turned on the punch in your teletype. And all of a sudden I'm seeing I have a bit of a problem here, because I do E, I have to leave this switch to the terminal to type the two escapes, but then I have to reach over and switch to B, and the punch has to come up to speed and online, and by then we'll have gone through several lines. So I'm going to need some sort of delay after initiating the E command before it starts punching, so that I have time to switch that AB switch and the punch has time to come up to speed. The other problem I have is this is coming out at 9600 baud. Everything's running at 9600 baud. That punch cannot keep up at 9600 baud. It can only do about 50 characters per second. And so we're going to have to somehow throttle this. And it was actually quite easy with these punches, because they used a handshake line, typically RTS, that would then go into your UART and automatically handshake. Now with the 6850 UART in this Altair 680, there's a CTS pin that will automatically handshake for us. We don't have to change our software at all, because when RTS is deasserted, then the 6850 does not assert transmit ready, which is the bit we are pulling in order to transmit data normally. So this would be great. It would just automatically work. All I have to do is hook RTS up to CTS on RTS from the punch to CTS over here in the 680. Unfortunately, the 680 did not expose the 6850 CTS pin to the rear connector. In fact, they just grounded it, which is asserted right there at the chip. And even if we cut that pin loose, there is no spare receiver on this board anywhere in order to bring in an RS-232 level of RTS and route it to that chip. So unfortunately, we can't use the handshake line. So the only thing I can see is that we're going to have to pace the output using delays. So if I put in about a 22 millisecond delay, I believe it was, then we get about 49 characters per second, just under the 50, to make sure we're not possibly overrunning this thing. So I see two patches. One, when we start the punch, we need a delay so that we can flip the AB switch. Number two, when we're punching, we need to have the character output routine put this delay in between each character so that we don't overrun the punch. Then another thing that we're going to need to do, and it'll be more obvious over on the assembler, is this prompt is going to come up at the end of the tape and get punched onto the tape if we don't put a delay at the end. Let's go over to the assembler and see how this affects the assembler. So if I go to the assembler, on pass, I don't know if that went in. Okay, you would do a 2T to punch a tape. And again, we have the same problem, as I have to hit return here. The assembler doesn't use escape, it uses a return. So that's just a side note for confusion. As soon as I hit return here, it's going to start punching. I'm not going to have time to flip that AB switch again. And also we have the problem of it coming out too fast. So the punch command, the 2T here in the assembler, we need to do the exact same things we talked about. We need a 3-second delay before we punch, and then we need to pace the output to not overrun the 50 characters per second throughput of the punch. But here's the other problem. You see this errors count and the pass prompt come out after we're punching. And if we don't have a delay at the end, these will end up on the tape, and I don't really want that either. So in the end, the modifications we need to make in order to use this much faster teletype, so to speak, is to have a 3-second delay for any punch command to give us time to switch the AB switch. We need character output pace to no more than about 49 characters per second. And then we like another delay at the end that allow us to switch it back. So I'm going to go ahead and write that code, and then we'll come back later and take a look at how to take that code and patch it into the assembler editor. So I've written the code to patch the assembler editor to work like we've described. Let's take a look at it here. If you take a look here, we're starting at 1C81. This is where we're going to put our new patch code, and this is right at the end of all the code of the existing assembler editor. And I'll show you in a minute how we're going to protect this code so it doesn't use it for symbol tables or the edit buffer. Right, so the first routine we have in here is called paste out. This is a replacement for the output character routine that's common to the assembler and editor. All character output goes through this routine, whether it's for the editor, whether you're punching tapes, it all comes through here. And normally this will do absolutely nothing different, and that is it takes the value in B and calls the monitor to output that character to the screen. And if punch flag is 0, it just exits. So in that case, it's no different than what was originally there. If this punch flag is non-zero, then we delay long enough to give us our 49 character per second rate. So now obviously we're going to need to set that flag and clear it if we are punching. So let me go down to that real quick. Let's see, 19 lines, type 22. All right, so we have two entry points. One, we want to set that punch flag when we're starting the E command. That's the command in the assembler, the editor to write the buffer. And then when we're exiting that E command, we want to turn that flag back off. So these two routines do that. Here's starting the E command. We set the punch flag. Exiting the E command, we clear the punch flag. All right, so the other thing we want to do, though, is at the start of the E command is give ourselves a 3-second delay to allow us to switch the AV port. And then when we're done, we want to be able to switch it back. And so you can see we call a 3-second delay at both of these locations as well. All right, and then we have the exact same thing for the assembler 2T command, which is the second pass punch a tape command. Let's see, let's go about, 18 lines. All right, so here's the entry point for the 2T command, and then the exit point for the 2T command. So just like we did for the E command, we can now delay at the start, delay at the end to allow us to switch the AB switch for the punch, and then also set and clear that punching flag. All right, and then here's the actual delay routine that does a 3-second delay for us. Now, this this Altair 680 only runs at 500 kilohertz instead, so it took me a while to figure out why this didn't work. I'd forgotten that everything was half the speed. All right, so the next thing we need to do is hook into the assembler editor and actually patch code in the assembler editor to jump to our new routines. So the first thing we want to do is move the start of the edit buffer, which is normally at the 1C81 where we put our routines. We're going to bump it up to 1CD8 to make room for our code that we just showed you. And I found 3 spots where it referenced this. Now, interestingly, it's not always 1C81. We updated that to 1CD8. Sometimes it's 1 above, sometimes it's 2 below. That all depends on how the data was indexed. But all 3 of these were referencing that edit buffer. So now they all point past the patch we put in. All right, and then here you can see at this location in memory is where we're jumping to the new character output routine. Previously, that was the character output address for all the assembler and editor, one common point, so that made it easy. Here's where we're going to call the starting command when we're doing the E. Here's where we're going to call the exit process when we're doing the E command. And then likewise, we have the 2 patches for the 2T command as well. And that's the whole thing. So you may obviously wonder, how on earth did I know these addresses to patch? Excuse me. Fighting a bit of a cold, apologize. The answer to that is I had a listing of an automated disassembly of the assembler editor. Now, you probably wouldn't have found one of those for the 680, at least not that I know of. People had written them for the Altair, for the Southwest Technical 6800. An automated disassembler for these early processors was not difficult. People even did them in BASIC for that matter. So you might have had a friend with a Southwest Technical 6800 and he could run a disassembly for you, or possibly you had cross-assembly tools to assemble and disassemble 6800 code on a mini computer at work or at school or something. But yes, without a disassembly listing, I couldn't have done this very easily. But I didn't have to do much besides just stare at the automated listing, no formal symbols or anything, and it wasn't hard to figure out where all this was. All right, so let's go ahead and compile these patches, or assemble them, I should say. First pass, run it manually. And then the second pass where we get our listing out here. All right, so now after we do this, we're going to want to punch this to tape, because the way we're going to use this, will be to load the assembler editor from the big tape like we showed you at the beginning of this video, and then turn around and load the output of this assembly right here, which will patch the assembler editor. Then we can jump to it, and it will work just like we want. But now I've got a chicken and egg problem. If I want to do this 2T command, we got the problem that it's, we have the problem that it's going to come to the serial port before I can switch that port. So I can't punch this yet. So to get around this, I actually hook my teletype up to our ABC switch so that I can switch to port C and run the teletype. But the teletype's at 110 baud. However, long before this project, I put a little switch on the motherboard of my 680 to switch between 9600 and 110 baud because I often switch between a terminal or terminal emulator and my teletype. So what I can do is flip this to C, flop my switch on the side of the motherboard to 110 baud, and then on the teletype do the 2T and turn on my punch and get my tape. So I'll do that, and then we'll set this up and come back and load that back in. All right, so we are starting over here now. I have loaded the assembler editor using that big tape, and it's the original one that doesn't have our patches. And I have the small patch tape we made, not much to it. Put that in. And this is the patch tape generated by that file we were just looking at. So let me go ahead and do an L command. Switch this to B and read. Switch back to A. All right, let's take a look over here now. Hopefully this will be working like we expect. I'm back, so now if I jump to 0107, we are back in the editor. And this should be our patched version. Okay, nothing in the edit buffer at all right now. So let's go ahead and load that Hello World program we were working on. Put it over here into the reader. And I'll do an I, switch to the reader, read. Back to the terminal. All right, and hopefully that's in there now. Okay, here it is, and we still have our old tape because we never wrote a new one. So let's change the 5000 to 3000 like we did. Let's see, begin, change 5000 to 3000, and change Altair 680 to Hello World. All right, so we're at 3000, we have Hello World. Let's go to the assembler. First pass, second pass. All right, if I exit, I should now be able to run that, jump to 3000, and we got it. All right, so now here's where we got stuck earlier. Now what we want to do is save this tape. But now we have the delay we need to do it. At least we hope we do. Let me just run it here on the screen and see. If I type E, escape, 0, 1000, 2, 1000, 3, 1000, there we go. And now you can also see that it's coming out slower. This is the paste output needed by the punch. Okay, so this looks like it's going to work. Let me let this finish, and then we'll go ahead and punch our tape. So here's a 3-second delay at the end, and now we got our prompt back. Perfect. Okay, so let me turn on the punch. Now let me pull back here for you. All right, turn on the punch, and hit E, escape. Flip this within 3 seconds, and then it should start. All right, there we go. That's punching that 50 characters per second. Now this particular punch I have can actually go 75. Oh, now we got to switch it back before the 3 seconds is over. All right, so now we should be able to turn around and load that tape. So let me clear this out. Begin 99 kill. All right, so nothing's in there. We'll go ahead and stick this tape into the reader. All right, so we'll do the in. Flip to B and do a read. Back to A, escape. There's our program. All right, and we can also now generate our tape. So if I go to the assembler, I think that did a 1P. Let me just make sure. All right, now we want to do a 2T. And again, now this thing will allow us to flip our switch over to punch that little tape. So let's go ahead and look at this. I'll hit return, flip this within 3 seconds. There's the whole thing, flip it back. And you can see we were able to miss punching all of this stuff onto that tape. All right, so now I've got an actual program tape I could load having nothing to do whatsoever with the assembler editor package or any of that. So let's go ahead and demonstrate that. I'm going to go ahead and turn this computer off. Wait a couple seconds, turn it back on. Alt, reset, run. All right, there's our prompt. All right, I'm going to stick that little S record tape we just punched with the Hello World program into the reader. So now I can do a load, switch to the reader, hit read. That's done already. Back to the terminal. Now if we jump to 3000, our Hello World program's there. All right, so we're in good shape now. We have got high-speed reader that allows us to load all of this in just a matter of a minute. The punch tape, we just load that right after loading the first big one. And now we can load, punch, save all day long. Still paper tape, still a bit cumbersome there, but boy, is it a heck of a lot faster than using the teletype. All right, so now in the next video, I'm going to show you the same basic thing, but we're going to make basic work this way. And we won't go into as much detail because we've already seen it. But we're going to use the cassette basic, and we'll make the C load and C save commands actually work with this paper tape.